Hi all, today we're going to be continuing our discussion of significant figures, and today we're going to be looking at how if you collect some data, how do you tell which figures are significant, what do you write down, and if you're looking at data that has already been measured by someone else, how do you tell in that data what the significant figures are. So the first thing, when we're talking about what significant figures are, remember that the number of significant figures tells us about the quality of the tool that was used to make that measurement. In our first video, we went through and we explained how the quality of the tool affected the quality of the data and therefore the number of significant digits that you can have. And also remember that all of the digits in a measurement are important, but there are two kinds of digits in a measurement: significant digits and placeholders. And zeros are the things that cause problems sometimes, because a zero can be either a significant digit or a placeholder. Non-zero digits are easy, they're always significant. But zeros, because they play two different roles, either placeholder or significant digit, those are the ones that kind of cause problems. So let's take a look at several data numbers and talk about the significant digits in them. So I've got three measurements here: 105 meters, 100 meters, and 100.0 meters. The rules for significant figures are these. First, any non-zero digit is a significant digit. So it's the zeros that cause problems. Second rule deals with zeros. Any zero that's the last digit in the number, and that "and" is important here because the zero has to fit both of these criteria. It's got to be the last digit in the number, and it's got to be to the right of the decimal point. If it fits both of those, last digit in the number and to the right of the decimal point, then it's significant. If there's a zero that's in between two significant figures, then that zero is a significant digit as well. So any other zero then doesn't fit those criteria. It's not a significant digit. It's just a placeholder. Now remember, it's still important. The number 100 has only one significant digit in it, but those two zeros are important. You can't just drop them out. If you leave them out, then you only have one, and 1 is not the same number as 100. So let's apply these rules to some data. Here are some measurements. 650 kilometers, 1250 volts, 455 watts, 600 light years, 0.0130 microns. Let's just go through each one of them and figure out how many significant digits there are. In that first one, 650 kilometers, let's just run down the rules. Any non-zero is significant. So that 6 and the 5 are significant digits. Second rule, any zero that's the last digit in the number and to the right of the decimal point is significant. Well, that zero that's left is the last digit in the number, but it's not to the right of the decimal point. It's to the left of the decimal point. So the purpose of that zero is to push the 6 and the 5 over into the correct places. Pushes the 6 over into the 100 spot and the 5 into the 10 spot. It's a placeholder. It's not a significant digit. That number has two significant digits, or two sig figs. Let's take a look at the next one, 1250 volts. Just run down the rules. First thing, any non-zero is significant. So that means these three, the 1, 2, and 5, are all significant figures. That zero, go down to the next rule. It is the last digit in the number, but again, it's to the left of the decimal point, not to the right of the decimal point. That zero is a placeholder, not a significant figure. That measurement has two sig figs. Two sig figs? That's wrong. That has three sig figs. The 1, the 2, and the 5. Next one, 455 watts. That's an easy one. First rule takes care of it. Any non-zero digit is a significant figure. All three of those are significant figures. Next one, 600 light years. First rule, the 6 is a non-zero digit. It's significant. Second rule, any zero that's the last digit in the number and to the right of the decimal point. Well, that third zero, or that last zero, is the last digit in the number, but it's to the left of the decimal point. There are no more significant digits. That one has only the 6, one sig fig. Last one, 0.0130. When we apply our rules, First thing, the 1 and the 3 are significant because they're not zeros. Now, the 0 to the right of the 1 and the 3 is the last digit of the number, and notice it's also to the right of the decimal point. That 0 is also a significant digit. And if you think about it, why would anybody write that other 0 if they didn't need to? What's the difference between writing 0.0130 and 0.013? Well, you're trying to show the reader that that measurement was accurate out to that 10,000th spot. So that is a significant figure. That measurement has 3 sig figs. So let's then take a look at writing numbers and showing the correct number of significant figures. Remember, when you write a measurement, you always guess at one doubtful digit. So that means if you're measuring, say, like with a meter stick and it has no marks on it at all you have is a stick that's 1 meter long, you measure the meter and then you guess at the nearest tenth. If you've got a meter stick that's divided up into tenths, you measure to the nearest tenth and then you guess at the hundredth. If it's divided up into thousandths, you measure to the nearest thousandth and then you guess at the 10,000th. So you always guess. That doubtful digit is always one order of magnitude smaller than the smallest number on the tool. So again, the problems are going to be with zeros because the zeros can be either significant digits or they can be placeholders. The final 0, remember, is significant, but it's got to be to the left of the decimal. So suppose we've got a measurement like this, 3,500 meters. How many significant figures in it are there? Well, there's 2, the 3 and the 5. The 2 zeros are not significant. But what if you measured this with a tool that made that last 0 significant? You were actually measuring out to the nearest meter. Well, how can you write that number and show that that last 0 is significant? Well, some people say, well, just put a 0.0 on it. But you can't really do that, because if you put that 0.0 on it, now it means you've got 5 significant figures, and the measure is only accurate to 4 significant figures. So generally what we do is we write a number like this. We'll just put a decimal point at the end and then nothing after it. And so if you see a number written that way, it means that that 0 that's just to the left of it is a significant figure. So this measurement was accurate to 4 significant figures. Another way you can do that is to write the number in scientific notation. Remember, when you write a number in scientific notation, you only show the significant figures. So let's take a look at another number here. Here's one. The speed of light is 300 million meters per second. But let's say we've measured this accurate out to this spot right here. That 0 is significant. The rest of them are all just placeholders. Well, how do we write this number to show the correct size and the correct number of significant digits? Well, when we put it in scientific notation, remember we put the decimal point, so there's only one significant figure to the left of it, or the left of the decimal point. That means the decimal point has got to be moved from where it is currently until it's just before the 3. So in scientific notation, this number is going to be 3 point something times 10 to a power. So how do you figure out the power? Well, you just count how many places you had to move the decimal point to get it in the location where there's only one significant figure to the left of it. Excuse me. So in this case, you've got to move it 1, 2, 3, 4, 5, 6, 7, 8 places. So you write that as 3 times 10 to the 8th meters per second. And if you've got a small number like this one, 0.0000450 meters, same thing. You move the decimal point till you've got only one significant digit to the left of it, and the first significant digit in this case is the 4, so it's going to be written as 4.50 times 10 to the something, and the power that you put in for the power of 10, you just count how many places you had to move the decimal point to get it there. In this case, you had to move it to the right 5 places, so that one would be 4.50 times 10 to the negative 5th. And notice that trailing 0, last digit of the number, is still to the right of the decimal point. So the last digit is a 0 and is to the right of the decimal point. It shows that all those digits are significant.